This is the video for the notes on section 3.1, slides 2 through 5. So section 3.1, we're talking about derivatives of the inverse trig functions. So the first thing that we need to do is we need to discuss just a review of the inverse trig functions. So for instance, we need to discuss an equation like y equals the inverse sine of x, okay, which could also be written as arc sine of x. These two notations are used interchangeably, and you have to make sure you know that the negative first power looking thing right there does mean arc sine means inverse sine. So what you have to remember is that if we look at the regular y equals sine x function from a graphical perspective, we get something like this. Looks like that, one period that way, and then another period this way. And of course, remember, it does continue forever in each direction. Now, the problem is that this function is not a one-to-one function, meaning it would fail the horizontal line test. So what we said we needed to do was we need to restrict the domain. So we restrict the domain to be from negative pi over 2 to positive pi over 2. And so we get this new function, which is actually just this restricted domain function, which we call the capital S sine of x function, or also known as the principal sine function. Now, if this function is one-to-one, so then we can find its inverse, and its inverse is the inverse sine. So the graph of the inverse sine function starts down here, and it goes like this, right? So it goes from negative pi over 2 down here to positive pi over 2 here, and from the left of negative 1 to the right to positive 1, right? And so what you need to remember is the angle now becomes the y value. So when I say the inverse sine of negative 1, that is asking what angle has a sine value equal to negative 1. And that answer would be negative pi over 2, right? So it's important to remember that the principal sine function is restricted to be from negative pi over 2 to positive pi over 2. All right. Next, then we talk about the inverse cosine, right? So y equals inverse cosine of x, or arc cosine of x. All right. And so just like this, we look at the y equals cosine x function. So if I draw y equals cosine x, remember it starts at its max, ends at its max. So we get something that looks like this. All right. And then that means we want to restrict the domain once again. So the restricted domain for cosine is going to be from 0 to pi. So we get this portion of the graph. And so the capital C cosine x function is restricted to be from 0 to pi. And that would give us the following graph if we graph it. So then we start, so 0, 1, right, becomes 1, 0. And then we actually go this way, and we end right there at negative 1, pi, right? So the x and y switch, and this point right here, the y-intercept actually would be 0, pi over 2. All right, and so when we think about that, we say something like, what would the cosine inverse of 0 be? Well, that would say what angle has a cosine value equal to 0? That would be pi over 2. All right, so that's inverse sine, inverse cosine. All right, and then also we should recall inverse tangent. So y equals inverse tangent of x, which could be arc tangent of x. All right, so if we look at the graph of the tangent function, we get this, which has an asymptote at pi over 2 and negative pi over 2, but then remember it's periodic, so the same thing continues, right? So we have this, right? But once again, this is not one-to-one, and so then we would need to restrict the domain. So the domain in this case is restricted to be just in between those two asymptotes. And so we say from negative pi over 2 to positive pi over 2. But it's important to remember there are asymptotes there. So the capital T tangent x function is restricted to be between negative pi over 2 and positive pi over 2, but not including those. So we use parentheses rather than brackets. And so then what does the inverse tangent graph look like? Well, it actually looks like this. And it has a horizontal asymptote of positive pi over 2 and a horizontal asymptote of negative pi over 2. So this is an example of a graph that has different asymptotes to the right and to the left. All right. And so something, if I said like the inverse tangent of 1 would be what? Well, that would be when x is 1, what would the y value be? Well, remember, we're saying what angle has a tangent value of 1? That would be pi over 4, right? So this would be pi over 4. So some things about inverse trig functions that we want to make sure we remember. All right, so then we're going to use this when we are developing the derivative rules. All right, so the first one, the derivative with respect to x of the sine inverse of u. All right, so first of all, we want to do is we want to say, let's let y be equal to the inverse sine of u. Now, what this really means is that we're looking for dy dx. All right, now, if y is the inverse sine of u, then we can say that the sine of y is equal to u. All right, and so what we're going to do is we're actually going to take the derivative of each side here. All right, so now what is the derivative of the sine of y? Okay, with respect to x. So we're going to say d dx of the sine of y. All right, and then d dx of u, right? Well, okay, on the left side, what is the derivative with respect to x of the sine of y? So remember, the derivative of sine is cosine of y, but then times dy dx, don't forget about the chain rule, equals, on the right side, just du dx. All right, now, what did I want to find? I wanted to find, look over here on the left, dy dx. So I'm going to divide by cosine of y. So dy dx is equal to 1 over the cosine of y times du dx. Now that looks great, but there was not a y in my original problem. So now we need to think about this. What is y? Y is the angle, isn't it? All right, and so if I draw a right triangle here, where y is the angle, our original thing said that y is the inverse sine of u. In other words, sine of y is u. So what does that mean? That means the opposite side must be u, and the hypotenuse must be 1, right? The sine of y is u over 1, which means, according to the Pythagorean Theorem, that the third side here would be the square root of 1 minus u squared. Everyone agree with that? So if you're not sure, let's go on the side here. Well, if this is u and this is 1, I would say u squared plus, let's call this other side a squared equals 1 squared. So if I want to solve for a, I get a equals plus or minus the square root of 1 squared minus u squared, right? So a is either positive or negative. Now, if you think about it, remember that the inverse sine function is restricted to be between negative pi over 2 and positive pi over 2. So that means the horizontal part must be positive because we're in either quadrants 1 or 4. So we get positive square root of 1 minus u squared. All right, so let's go back over here. All right, what does that mean? All right, dy dx then is 1 over cosine of y. So look at the picture. 1 over cosine is actually, well, the reciprocal of cosine. So what would the cosine of y be? It would be the square root of 1 minus u squared over 1. So we can say the reciprocal of that is 1 over the square root of 1 minus u squared times du dx. And so that is the rule for the derivative of the inverse sine of u. It is 1 over the square root of 1 minus u squared times du dx. All right, so that's the rule for the derivative of the sine inverse of u. All right, so now let's do the same thing for cosine. So once again, I'm going to let y equal the inverse cosine of u, which means that the cosine of y is equal to u. So now I'm going to take the derivative with respect to x of both sides. All right, so I have d dx of the cosine of y, and then du dx. All right, so what is the derivative with respect to x of the cosine of y? It is negative sine of y times dy dx equals du dx. So now, once again, I want to solve for dy dx. So what is dy dx? Well, dy dx would be 1 over negative sine of u sorry, that should be the sine of y over there, and 1 over the sine of y du dx now on the right side. All right, so now, just like we did a minute ago, we're going to draw a right triangle, all right, to figure out what the sine of y is. So once again, y is the angle, but now in this problem, cosine of y equals u, so that means u over 1. So the adjacent side is u, which means that the opposite side in this case is the square root of 1 minus u squared, and it should be positive because remember, cosine is only used in quadrants 1 and 2, therefore the vertical part always has to be positive. And so we see 1 over the sine of y. So in other words, the reciprocal of sine. So the sine of y would be the square root of 1 minus u squared over 1. And so we get that dy dx is, I'm going to use the negative here, and then 1 over the square root of 1 minus u squared du dx. So that is the rule, negative 1 over the square root of 1 minus u squared du dx. All right. So same thing is what we're going to use to find the next ones. All right, so derivative of tangent of u. So once again, we're going to say, okay, y equals tangent inverse of u. So that means the tangent of y is equal to u. So now let's draw our triangle right away. The tangent of y is u. So the angle is y. If the tangent is u, that means opposite over adjacent. So now what does that mean? Now Pythagorean Theorem, all right, what would we say? We would say that 1 squared plus u squared is equal to the hypotenuse squared. So how do I solve for the hypotenuse? That would just be the square root of 1 squared plus u squared. Squared, right? I apologize. So h squared is 1 squared plus u squared, right? So I would actually put the square root of 1 squared plus u squared, right? All right, so now I'm going to take the derivative with respect to x of both sides. So once again, du dx there. All right, so what is the derivative with respect to x of the tangent of y? Derivative of tangent is secant squared of y times dy dx equals du dx. So now solve for dy dx. All right, so solve for dy dx, I divide by secant squared. So dy dx equals 1 over the secant squared of y times du dx. All right, 1 over secant squared, that's actually just cosine squared. So dy dx is equal to cosine squared of y du dx. All right, so now what would cosine of y be? Well, cosine of y would be 1 over the square root of 1 plus u squared, but if I square it, I get 1 over 1 plus u squared, du dx. So the rule for tangent, 1 over 1 plus u squared du dx. All right, cotangent is going to work in a very similar fashion. All right, so we let y equal cotangent inverse of u. So then we let cotangent of y equals u. So now take the derivative with respect to x. So what is the derivative with respect to x of cotangent y? Well, derivative of cotangent is negative cosecant squared of y dy dx equals du dx. So then we want to solve for dy dx. So dy dx is, now I've got the negative, so I'm going to say negative 1 over cosecant squared y du dx. All right, so now once again, let's draw a right triangle. So now it says that cotangent of y is u. So if this angle is y, cotangent would mean that u is the adjacent side and 1 is the hypotenuse. But still, 1 is the opposite side. But still, that means that the hypotenuse is still the square root of 1 plus u squared. All right, so then that means that 1 over cosecant squared, well, that would actually just be sine squared. So I get that dy dx is negative sine squared of y du dx. So negative sine squared. Well, what is sine? 1 over the square root of 1 plus u squared. So sine squared would be negative 1 over 1 plus u squared, and then the du dx. So negative 1 over 1 plus u squared du dx. All right, so now, lastly, we have the derivative of secant and cosecant. All right, so almost the exact same thing. All right, so let's let y equal secant inverse of u. So secant of y equals u. Okay, so now I'm going to draw a right triangle. Okay, so secant of y is u. So now y is the angle once again. So the secant of y is u. So that means what? The cosine of y is 1 over u. So what does that mean? That means the hypotenuse is u and the adjacent side is 1. So that means that the third side is going to be the square root of u squared minus 1. All right, and we could show the Pythagorean theorem, but we probably don't need to. All right, so now I'm going to take the derivative with respect to x of both sides once again. All right, and so I get the d dx of secant of y. What's the derivative of secant? It's secant y tangent y dy dx equals du dx. So now solve for dy dx. So I get that dy dx is equal to 1 over secant y tangent y du dx. So now 1 over secant, that would be cosine. So what is cosine? That's 1 over u times 1 over tangent, that's cotangent, or the reciprocal of tangent, okay, which would be 1 over the square root of u squared minus 1, and then times du dx. And so I get 1 over u times the square root of u squared minus 1 times du dx. So now almost exactly the same is going to be cosecant. So y equals cosecant inverse of u. So cosecant of y equals u. So now our right triangle, that would now mean the cosecant of y is u, which means the sine is 1 over u. So 1 adjacent side, u hypotenuse, which means the adjacent side would be the square root of u squared minus 1. All right, so now I take the derivative with respect to x. So du dx. All right, so derivative of cosecant is negative cosecant y cotangent y dy dx equals du dx. All right, so now divide and solve for dy dx. So dy dx would be the negative 1 over cosecant y cotangent y du dx. So now cosecant, that's, well, 1 over cosecant is sine. So what would sine be? 1 over u. So I have the negative 1 over u times 1 over cotangent is tangent. So 1 over the square root of u squared minus 1, and then the du dx. So negative 1 over u times the square root of u squared minus 1 du dx. So those are the 6 rules for the derivatives of the inverse trig functions.